video we will discuss the density. We have three main points that we will cover in this video. First one, the meaning of density, then how to calculate the density, and the last one is the factors that can affect the density. First, to understand the meaning of density, let's imagine that we have two objects. First one is a piece of iron, and the second one is an air balloon. If we measured the mass of both of them, we'll find that, for example, the mass of the iron piece is 500 grams and the mass of air balloon is 10 grams. So we understand how the small piece of iron gives us a higher mass than the large volume of air balloon. The main difference between them is related to the particles inside both of them. If we looked inside the iron, we'll find that the particles inside the iron is heavy particles, and they are tightly packed. They are near to each other. There is no gaps between them. But inside the air, we will find that the particles are smaller or light particles, and they are far apart from each other. So inside the iron we have heavy particles, and they are close to each other. But inside the air balloon they are small particles, and they are far apart from each other. So the small piece of iron contains a huge amount of particles, and they are heavy. But the huge volume of air balloon contains a small amount of particles, and they have a small mass. So that is what we call the density. The density is related to two main properties inside the material: the particles heavy or not, and they are close to each other or not. The higher density material, or the high density material, contains a huge particles or heavy particles, and they are tightly packed, or they are close to each other. And the material with less density or less dense material contains small particles, and they far apart from each other. So we can say that the denser material will contain a crowd of particles inside it. So the more crowded material will be higher dense material. From that we can conclude that the density of iron is higher than the density of air. To calculate the density, we need to know two main things. The first one is the amount of particles inside the material, and the other one is the volume that they occupy. The symbol of density that we will use is the Latin letter called rho. So we will write the density in form of this letter. From our previous study, we are knowing that the amount of particles of matter inside the object is called the mass. So if the amount of particles increased, between two brackets the mass of the object increased, that will give us a higher density. So the first thing that we need to know to calculate the density is the mass of the object. But to know if the density is high or not, we need to know the volume that these particles occupy. So we need to know the volume also. So we can say that the density equals mass over volume, and we can write it in form of this triangle. The density, which is rho, equals mass over volume. To get the unit, we can get the unit from the rule. We know that the mass can be in gram, and the volume can be in centimeters cube. So the first unit of density that can we use is gram per centimeter cube, and also the mass can be in kilogram, and the volume can be in meters cube. So the second unit that can we use with density is kilogram per meter cube. So the units that we can use either to be gram per centimeter cube or kilogram per meters cube. We can represent the density also on a graph between the mass and the volume. We can put the mass on the y-axis and the volume on the x-axis, and let's assume we have a straight line like this. If we calculated the slope of this graph, we know that the slope equals y-axis over x-axis. So in this graph it will be equal the mass over the volume, and we know that the mass over the volume will give us the density. So we can say that in the graph between the mass and the volume, the slope of the graph equals to the density. The following point that we will discuss are the factors that can affect the density. First, we say that the density is a physical property. The word physical property means that the density will not change unless that you change the material itself. So the word physical property means that the density is related to the type of the material. So the first factor that can affect the density is the type of material. The factors inside the material that control the density, the first one is the atomic mass of the element. If the atomic mass or the mass number of the element increased, the weight or the mass of the object will increase, so the object will be heavier, so the density will increase. And the second factor is the intermolecular space. The intermolecular space is the distance between the molecules of the material. If the distance between the molecules of the material increased, the particles will be far apart from each other, so the density will decrease. So we can say that by increasing the intermolecular space, the density will decrease. And the last thing is the arrangement of the particles, if they are tightly packed or they are apart from each other. The second factor that can control the density or change the density is the temperature. If we got an iron rod like this and we start heating it, after a few seconds the particles will gain energy. So they will start move, and when they start moving, the distance between them will increase. So they will take a larger volume like this, but as they will move away from each other, the density will decrease. So we can say that by increasing the temperature, the energy of the particles will increase, so the motion of the particles will increase, so the density will decrease. And the last factor that can change the density, but it can change the density of gases only, is the pressure. If we got an air balloon like this and we start producing a pressure on it, if we apply a pressure on the air balloon, the volume of the air balloon will decrease, but the number of particles will not change, so they will be closer to each other, which will mean that the density inside the air balloon will increase. So we can say that also by increasing the pressure of the gases, or the pressure on the gases, the density of the gas will increase. The following point that we will discuss the sinking and the floating. If we got an iron piece on the surface of water like this, the density of iron is higher than the density of water, which will mean that the downward force from the iron will be stronger than the upward force from the water, so that the iron will sink inside the water. And on the other hand, if we got a piece of cork or wood, the cork or the wood have a density less than the density of water, which means that the upward force from the water will be stronger than the downward force of the wood. So the wood or the cork will float on the surface of water. So we can say that if the object has a density higher than the water, it will sink inside it. And if the object got a density less than the water, it will float on the surface of the water. This question is from the course book. He gave you a graph between the mass and the volume, and he asked you which two objects have the same density. We said that when we have a graph between the mass and volume, the slope of the graph will equal the density. So the objects with the same density should have the same slope. Let's draw straight lines for each material. The first one will go this line, and this will be the slope of the first one. And the second line will be this one, which will pass through the material 2 and 3. And the last one will be this one. So to have the same density, we should have the same slope. And on the graph, to have the same slope, we should lie on the same straight line, to have the same angle between the line and the x-axis. So from the drawn lines, the two materials that got the same slope is the material number 3 and number 2, as they are lying on the same line, so they will have the same slope, so they will have the same density. So the answer will be the material 2 and the 3.